today's session. Uh, I hope you can hear me clearly this time. I'll be presenting more towards the blockchain use case that we were working on, and um, so I'll work as much as possible the work that we have already done on track and trace service from Nimble side. Yeah. So today's agenda will be I'll be talking about the use case that we worked on for the factory EFPF use case. So track and trace service with blockchain, and about the Nimble blockchain technology that we introduced, about the smart contracts and workflows, and the extendability of smart contracts that we have, and the blockchain clients and the gateway that we developed, as well as the deployment of the blockchain node, and then about a little bit about the BC standards that we are following in order to capture RFID data on the logistic process. So in track and trace with the blockchain, we basically use blockchain to as a data provenance and verification engine for trading and logistic data exchange between trade partners in Nimble platform, and for the trade partners redirecting to Nimble from EFPF platform. So this is basically a feature which was developed for the base platform Nimble. So what we are mainly focusing is the logistic process after a supplier dispatches an order. So there will be a few steps on this logistic process. There can be few steps. So yeah, we are actually focusing on the data that we are getting on each step on this track and trace service. So type of trade data to be exchanged is products moving through different stages of logistic, from dispatching to delivery to warehouse to shipping. So there can be kind of a different logistic process than this. There can be less number of steps, or there can be more number of steps. We give kind of ability for the end users to define their own template for the logistic process, but as a standard, we are giving kind of a process template from the beginning if they want to enable the logistic track and trace service through Nimble. And also we track the ownership of the products at different stages of logistic as well. So the custodian at each level, the owner at each level who holds the product after the dispatchment. So we are tracking that as well. So the goal is to provide an audit trail for supply chain data, to provide a mechanism to verify the authenticity, provenance, and conformance to agreed standards. So we're using EPSA standard for this process. When it comes to data standards, yes, we're using EPCIS, Electronic Product Code Information System. So this is a GS1 standard for business communication that enables trading partners to share information about the physical movement and status of products as they travel throughout the supply chain or logistic chain. EPCIS actually answers the what, where, when, and why, who questions to meet consumer regulatory demands for accurate and detailed product information. So we can get kind of an idea about where is the product at the moment, and who is the owner, and when was it there, and where is it done, what is the product, so kind of product details as well. So the goal of EPCIs is to enable disparate application to create and share visibility on event data both within and across enterprise. So we are using EPCIs as a standard, as a data standard for our process. But the final goal of using blockchain and EPCIs is together is to create and share visibility on event data throughout the logistic process chain. So I'll move on. So that's about the use case that we were targeting to deliver to EFPF platform. So then I'll talk a little bit more about the involved technologies which are actually not related to blockchain stuff, but which helps us to build the infrastructure that we need in order to create this whole process. So we have EPCI as a Spring Boot server, which is kind of a service that acts as the interface to capture events from RFID tags based on items which are currently in logistic process. So I will show you. It's currently hosted in Nimble staging environment. So we have a Nimble staging new environment. So um, if you have a look at the PCI Spring Boot server, it's the main endpoint where we capture RFID reading events, which are pushed from the logistic stakeholder premises. So here we support XML capturing as well as JSON event capturing as well. We actually got this from University of Bremen in Nimble platform use case, but we required a way to separate out a few things on this, and we had to do some modifications on this as well. So we had to separate out the Olio client, which is kind of uh, together with this Spring Boot server. So the Olio client is kind of a service which gives you the ability to define your logistic template. I'll show you that as well. So we worked on separating it out and defining the endpoints that we required for our use case. Apart from that, from the deployment side, we have integrated this into our CI/CD pipeline. If you go to, just give me a second, I can't remember the platform secrets. Go to our Nimble platform Jenkins instance. So we have APCI server separately there. We have our normal development process. We have master staging going on, like in our normal other Nimble services. So that's it about on the deployment side of it. And also we actually we actually wanted to take this service into our Nimble service infrastructure. So we had added Spring Cloud configurations, and you can find this EPCI server as a separate repository now. So it has kind of modifications that we required on the endpoints, as well as all the modifications on the Jenkins files and the Docker files that we required to build the Docker images. And and also you can find the Spring Cloud configuration that we use in order to take this service to up to our uh, service infrastructure in Nimble, because in Nimble we have a separate service API gateway with the service gateway that we use in Nimble. So Spring Cloud Eureka service. So we have that, and we required to take this into our server services infrastructure. So we have done the configuration required, and it's now in a separate repository, and you can have a look at this. So previously it was together with the Olio client, which is, as I mentioned, it gives you the ability to define the logistic process templates. So let's move on. I'll give you an idea what is Olio client as well. So EPCI's Olio client actually defines master data template and templates for the logistic process. This service is the management platform for EPCIs and defines the production template for us. The master template for an organization can be defined. This will be only exposed to platform admins at the moment, because we thought of it's how it was like. We are providing kind of a generic template to the end users, to people who are doing negotiation in the Nimble platform, and they can come up with their own template by going through the template that we are providing to them. So if you want to have a look at the Olio client, it's only possible via kind of tunnel. So I'll give you kind of overview how it looks like. So to people who have access to the Nimble staging new environment, we have done the deployment of the Olio client there. And the audio client is the place we define the logistic workflow, as I mentioned previous. So I will go in there, put 288. So this is the audio client. I can go inside there. So you can even catch events from RFID tags, like since we need the kind of separation that we required, we wanted to capture events and persist them on blockchain side as well through the EPCI server. So that's why we did the separation from this service and the service that I showed you, the EPCI Express API. So both were together and on the same repository and as same as a couple together, but we did kind of separation in order to get the kind of separation. So you can do some sort of event capturing. You can send like example events and capture them, and then you can push them these as events. But we are not doing that part. We are not taking that the usage of that in order to push example events. What we are doing here is basically we are defining our own logistic process template. So as I mentioned you in the previous slides, we have few logistic process stages that we have defined. So according to that, we have defined a process template, which should be uploaded during the negotiation phase by the negotiation party. So this will be provided to end users. If they want, they can come up with their own process template by going through the standard template that we are providing. So that's about the Olio client. Olio client. So this is also changed as the Spring Boot and Spring Cloud project, and also it's also you can find it in our Jenkins instance, and it's also there, and it's kind of getting built, and we have that in place as well, and it's also integrated into the Nimble staging environment at the moment. So you can have a look at that if you have access to the instance that Nimble new staging instance. I hope Felix and all the people in the call have access to the instance, so they can create a tunnel and have a look at the audio client. So uh, yeah, actually we require this audio client in order to define the process template, the standard process template. Other than that, we didn't see much requirement of this, so that is why we separated this out as a separate project and just gave the access to platform admins. So that's about audio client, and also mm, so as I mentioned, all these are deployed using the normal service Docker Composer that we have. If you go to, I'll go to the and show you the deployment as well. So if you go inside our machine, staging services. So this is the EPCI server. So we have done the deployment with the Docker Compose. So you can find it in our Docker setup in Nimble platform, as well as you can find it inside the Nimble staging new environment as well. So that's kind of an overview for you to have a look at the deployment setup of this service. So next, I'll show you the hardware as well. I think I kept track on that. Okay. So yes, if you find this, there are two Docker images that we are pushing always. So you can always refer this to Docker images that we have published. So during the Jenkins build process, we are publishing these as it is in other services as well. So to anyone who is looking for the contain the images Docker images in order to spin up the containers, yeah, it will be here in the Nimble platform Docker Hub itself. So that's a bit more about the services that we got from University of Bremen in order to capture the RFID events during the logistic process. So I'll move on and uh, I'll talk about the tracking analysis service that we have. Actually, we have another, it's also deployed at the moment in Nimble staging new environment. So this is kind of an intermediate layer between the Nimble client and the tracking service. It also acts as a warning notification handler. So what happens is we have kind of another advantage because of the EPCI's integration that we did in Nimble platform. So when we upload the template from suppliers and we are keeping track of the time it takes from one process to another. So I'll show you what I'm talking about. So this is the kind of process template. It's a little bit longer, but I couldn't fit it to the slide. So if you look at here, for one process to stay in one step, we have defined the duration it has to take. So the duration to next, so it can only stay 1 hour inside this business step. So we are targeting this process template, this data that we have get, and we are checking whether we have received any events within this time that we have defined, that they have defined in the process template. If we haven't received any events during this time, then we are sending warning alerts to the stakeholders who are involved in this logistic process. So this is also another use case that we have come up with from Nimble platform. So this is kind of a cron job running daily every morning. It checks what are the logistic processes ongoing in Nimble platform, and if there are any processes that due and we don't have any events related, then we are sending notifications, warnings to the stakeholders. So that's why I said it's kind of acting as the warning notification handler for us on the Nimble platform. Basically, this service also kind of new service, and it's also was being cloud service, and it's also in the Jenkins setup. You can have a look at that. So tracking analysis service also, they are deployed at the moment in Nimble staging new environment, and you can have a look at the Swagger documentation. I'll share you the slide. I'll put it on the on cloud, and you can have a look at there. So we have two endpoints, which kind of gives us the estimated takes the estimated time for a process to end from the business process template that they are uploading. So that's kind of basic idea about the services which are not actually blockchain related, but these services we actually need in order to build the infrastructure that we require for this for the to develop the to develop our use case on blockchain. So just a second, I got a message from Felix. Yeah, sure. I'll add you later. I'll add you later, Felix. So apart from that, I want to show what is the JSON, what it looks like when we are capturing JSON event. It's already here defined in the Swagger spec as well. So we get sort of this kind of an event. What is the business step? What is the action? What is the read point? What is the business location? Event time? Event time zone offset. What is the EPCI's RFID attached to it, attached to the object? So we are getting an event like this in order to capture from the RFID from the stakeholder promises. So we are capturing a JSON object like that in this service. And this is again the BCI's defined template that I mentioned you earlier. So we are defining this from the audio client, and we are providing it to the stakeholders who are involved in the negotiation process. And according to this, they can define their own business process template. So it's not something like Camunda. We have not defined a direct workflow, a business process workflow, but we are just giving kind of configuration file to them, and they can do the template uh, update, and they can upload it during the negotiation process. So that's it about the services which are involved in our process. And yes, so there are quite a few supporting services, as you see. So I'll now move on to the architecture diagram of the implementation that we have done. So as you can see, we have one nimble deployment here, and or we have a hyperledger deployment here. So this is kind of a fabric deployment. We have nimble peer network. Sorry about that. So I'll just start from this side. So we have the nimble front end, and then we have business process service. So when a supplier dispatches an order event, then we are persisting an order details with the parties who are involved in this logistic process in the blockchain. We are persisting it when a supplier dispatches an order. Then as I mentioned you previously, we have a cron job event in tracking analysis service, which actually checks whether we have received an event within the time that we have defined in process template. It will always check whether we have received any events from the blockchain that related to the business process template that we have provided. If it's not there, it will send uh, mails to the stakeholders who are involved in. And also, this is the tracking service that I showed you previously, which captures all our JSON events. So JSON RFID events, so it will capture the events. Also, as I mentioned you earlier, we need this separation because we need to persist them in the blockchain as well from here. So we get the data to the tracking service, then we redirect that, then we persist that data from the tracking service into the through the Hyperledger client to the logistic blockchain state, world state. And we have the nimble logistic front end. At the moment we are using Hyperledger Explorer. It's not it's working at the moment. So it will check for the management events which are persisted at the moment in blockchain, and it'll show you what are the events that are going on. So anything yeah, so that's about the nimble side of integrations that we have. So now if we look at the Hyperledger deployment, so we have Hyperledger client and logistic client contract and nimble peer network. So Hyperledger client is the actual gateway, API gateway, which exposes the logistic contract. I mean, these are actually like Java controllers, the business logic of Java. So you cannot access this directly from outside world. There should be a client which actually connects to this logistic contract through gRPC protocol in order to expose these services that we have defined in contracts, in order to expose them as API endpoints to outside world. I mean, to all these integrations. So there is Hyperledger client, which exposes all these services that we have defined in logistic contract. So I'll show you what is logistic contract that we have developed, and what is the Hyperledger client that we have developed, and how to do the this nimble peer network deployment. I mean, how to build a network from the scratch. So I'll walk you through on this when we come to the particular places. But actually, before that, I think it's better to get an idea what is blockchain is, and otherwise there will be a lot of new technical terms coming up, and uh, I think it's always better to have a quick idea about what is blockchain and what are the frameworks that actually we are using, and in order to develop this use case, as well as to get a little bit more idea on what are the technical terms as well, so we can move forward and see on the deployment side and the development side. You'll get kind of familiarity when I describe them. So let's look at what is blockchain is. So in general term, a blockchain is an immutable transaction ledger maintained within a distributed network of peer nodes. These nodes each maintain a copy of the ledger by applying transactions that have been validated by consensus protocol, grouped into a blocks that include a hash that bind each block into the preceding block. So generally, a blockchain is kind of immutable transaction ledger, so it's distributed within the peer nodes. So for the moment, just think a peer as an organization which involves in this process, and these nodes each maintain a copy of ledger. So all the organizations by themselves, they manage their own ledger. Ledger is kind of, let's say it's a state. It's kind of records that you have. It's kind of a database that you have by each and every organizations involved in this process. They have their own ledger, which is synced with all these ledgers, so they have the same state. They should have the same state. If it's running perfectly fine, we have to make it should be perfectly. It should have the same state on the same on all the database that these organizations are maintaining. So that is what the advantage of using blockchain, and also to do the transaction validation, we are using a consensus protocol. So what is consensus is, for now, just think it like it's what keep the ledger transaction synchronized across the network. So consensus protocol stands between all these peers, and it will do kind of synchronizations of the states that we have in each and every state of the organizations that we are maintaining. So that is what blockchain is. So to talk a little bit more about it, and the first and most widely recognized application of blockchain, as we all know, is Bitcoin cryptocurrency. Through others have followed the footsteps, and like Ethereum and alternative cryptocurrency, they took different approaches, integrating many of the same characteristics as Bitcoin. But Ethereum came up with adding smart contracts to create platforms for distributed applications. So Ethereum first came up with frameworks in order to create smart contracts and give us the ability to create applications like this, as we are doing now. So Bitcoin and Ethereum fall into the class of blockchain that we would classify as public and permissionless blockchain technology. So we'll talk about what is permissionless blockchain technology next. And basically, these are public networks which are open to anyone, where participants interact anonymously. So there's when you think about Bitcoin and the Ethereum frameworks that they came up with, it's actually permissionless blockchain technology, and there's no identity inside the blockchain where they are participating in transactions. So but according to my view, for an enterprise use, we need to consider there are some aspects that we have to think about as requirements. So participants must be identified. So there must be kind of identity if we actually do performing transactions between these peers. Also, networks actually need to be permission, which means the participants are not anonymous; they have an IP again, and also high transaction throughput performance. So if one peer performs a transaction, it should be validated soon, and it should sync within the organizations as soon as possible. And low latency of transaction confirmation. So when we do a transaction try to change the state, actually we need all peers verification in order to submit the transaction and to change the world state of blockchain. So actually we need the verification from all these peers in order to submit a transaction to one peer. So in that case, we actually need something which actually can handle this transaction confirmation as soon as possible. So this is kind of things that we required from an enterprise solution, which we had to use. So again, next we'll talk about why blockchain is useful nowadays. Uh, today's system of records, we actually keeping business records from our own. We actually maintain separate records of our transaction by our own, and it's already there. It's been there. I mean, we are keeping records of the business records, and we are keeping track of the transactions that we are doing. But we have our own databases that we maintain in order to manage the transaction. Actually, there's no visibility, so that is kind of a downside that blockchain tries to address. The difference is blockchain network. In every participant, they have their own replicated copy of the ledger. So in blockchain, as I mentioned to you earlier, we have the ledger, the database, in the same database replication of one and each other. It's not like having a replicated copy to achieve the high availability. Like in that case, when you are developing a web application, yeah, we can have a second database apart from our main database, but that the sync between them will not happen in real time, and it'll happen anyways. It'll sync with the secondary database when it comes to the high availability, but it's not like that in this state change. I mean, this replication happens exactly on the right time. So if you think about using blockchain for simple web application, it's kind of nonsense, because it requires a lot of transaction, a lot of computational power, because we need, every peer need to verify one transaction, so it will take a lot of computation power. So for simple web applications, I don't think it's a requirement to use blockchain. So at the moment, there are actual use cases in the bank side and healthcare side which uses this blockchain technology at the moment. Yeah, basically these are to keep kind of traceability and get the kind of visibility throughout their supply chain network or logistic network, or even in bank loans. If you want to verify someone's identity and get set of documents that they have to provide to check the validity of those documents. So for these kind of purposes that they can use blockchain. Um, we actually, with the ability to coordinate the business network through a shared ledger, blockchain networks can actually reduce the cost and risk associated with the private information, and also it'll improve the trust and visibility, as I mentioned earlier. So this is the main advantages that we see using blockchain. uh, so yes, this is why blockchain is useful for us in scenarios like this. So next, I want to, as I mentioned earlier, we expect some of the key features for an enterprise data solutions. So as I mentioned to you earlier, we actually need a permissioned network where we can identify someone's identity, because we are actually in a process, logistic process or supply chain process. There'll be money involved. So we actually, that will be great if you can if you can handle if you can identify who is the identity actually providing the transaction, and lot of technology, I mean, a lot of sides of the technology, cloud native development and like Kubernetes technology. They are the key founders of that. and there are a lot of aspects they cover, and they have come up with they are coming up with frameworks and tools which will help developers to develop applications. Uh, so they have come up with frameworks which will help you to develop a permission network, a permission blockchain network. So we actually thought of using Hyperledger Fabric or Hyperledger Sawtooth. So there are two main frameworks which are developed by them. Actually, the Hyperledger Fabric is backed by IBM, and the Hyperledger Sawtooth is currently backed by Intel. And yeah, finally, yeah, we actually gave kind of look. We actually monitored them and just saw that Hyperledger Fabric is currently having a lot of support, and there's a great community behind it. So we thought of going with Hyperledger Fabric as the framework that we use in order to develop our use case, because we didn't see much involvement and much development in Hyperledger Sawtooth side. So what is Hyperledger Fabric? First, Hyperledger Fabric is an open source enterprise grade permissioned distributed ledger technology platform designed to use in enterprise context that delivers some key differentiating capabilities over the popular distributed ledger or blockchain platforms. Uh, Fabric also has highly modular, configurable architecture. It enables innovation, versatility, optimization for a broad range of industry use cases, including banking, finance, insurance, healthcare, human resources, supply chain, and even digital music delivery. Uh, Fabric is actually the first distributed ledger platform to support smart contracts. So I'll give you kind of an idea what is smart contract. Again, is smart contract for now. Just think it as the business logic or the controllers that we not the controllers, like the let's say like the the layer between controller and the data persistent layer. It's like the business logic that we are writing. So think smart contract like that in Java development or TypeScript development, something like that. So we have the ability to uh, develop these smart contracts with languages as Go, Node.js, Python, and now they support Java as well, rather than considering domain-specific languages. Like if we had to develop this by going into the core level of blockchain, it would have been very difficult, because we had to go to the domain-specific language and try to understand what's going on, then try to develop that. But they provide kind of ability, kind of separation for us. They give an abstraction layer for us, and like we are doing in Java, we have Spring Boot. Like in JavaScript, we have frameworks like uh, Angular, libraries like React. Likewise, we also have this Fabric as a framework, of Sawtooth as a framework, where we can write our smart contracts in either in Java or Go or Node.js, that from the language that we actually familiar with. So the Fabric platform is also permissioned, as I mentioned earlier, that unlike permissionless network, the participants are known to each other rather than anonymous, and therefore fully untrusted. So it's not fully untrusted. We actually know who are the stakeholders actually involved in this process. So that's kind of advantage that we seek. Actually, as I mentioned you earlier, we actually wanted to uh, work on a permission network. I'll let you know why is it why it's very crucial for us to work on a permission blockchain later on, because in permissionless networks, if you want to do this kind of application development, there should be some payment that we had to do from Bitcoin. So so that's why we seek for permission network. Uh, in Fabric, a network can be operated under a governance model that is built of what trust does exist between parties and participants, such as legal agreement or framework for handling disputes. So now we said Fabric is also a permission network. So what is permission versus permissionless blockchain? So in permissionless blockchain, virtually anyone can participate, and every participant is anonymous. As I said earlier, in a such context, there can be no trust other than that the state of the blockchain prior to a certain depth is immutable. In order to mitigate the absence of trust that we have here, permissionless blockchain typically employs mind native cryptocurrency or transaction fees to provide economic incentive to offset the extraordinary cost of participating in form of fault tolerance based on proof of work. So if you want to develop something on a permissionless network, so the cryptocurrency or transaction fees have to be provided. So that is the mitigation method that they have followed, fault mitigation. I mean, it's kind of a fault tolerant method that they have followed. So if you want to develop an application on a permissionless network, so there will be some kind of transaction fee in order to provide the transaction, and you have to do, if you want to do some kind of proof of work. So in the other hand, permission blockchains, on the other hand, it operates among a set of known and identified participants under a governance model that yields certain degree of trust. So we know who are the actual people involved in this process. A permission blockchain provides a way to secure the interaction among a group of entities that have a common goal, but which may not fully trust each other by relying on the identities of the participants. So basically, we actually more focusing towards the identity of the trans of the participants. So that is what the key differences between permissioned and permissionless blockchains. Uh, so now I just want to show you the what are the some of the keywords that we have in Hyperledger Fabric. So we have assets. Assets are like the entities that actually uh, uh, are working inside the state. I mean, in Java also we are defining a set of classes that we want to interact with, and we want to persist in databases. Likewise, we have assets. Asset definition enables the exchange of almost anything with monetary value over the network, from whole food to antique cars to currency futures. And what is a chain code? Chain code execution is partition from transaction ordering, limiting the required level of trust and verification across node types, and optimization network scalability and performance. So chain code is exactly the smart contracts in Hyperledger Fabric. The difference between chain code and smart contract is there can be multiple smart contracts in one chain code in Fabric. Still they're using they're saying, okay, this chain code is smart contract. And ledger features the immutability. The shared ledger encodes the entire transaction history for each channel and includes SQL like query, so you can do the ledger querying uh, like doing SQL queries. Actually, finally, when we dig deep into this, it's somewhat similar to what we are developing in Nimble. We have a service and there's a database in the backside of it. We have PostgreSQL. Likewise, in Fabric, we have smart contract, which is same as the Java code that we are writing, and the data persistent layer of the Java side. And there's a database, CouchDB database. Likewise, in Nimble, we have PostgreSQL. So we are persisting this data into this CouchDB. So that's what happened when we actually dig deep into these concepts. We saw that it's actually what happens. And privacy, the channels and private data collections enable private and confidential multilateral transactions that are usually required by competing business and regulated industries that exchange assets on a common network. Also, the security and membership services, as I mentioned you earlier, the Fabric is permission network. So they actually kind of maintains how to manage the membership services. They have their own certificate authorities that provide the certificates for each and every kind of parties. I mean, for organizations, to the peers, to the orderers. These are kind of components. So I'll let you know what are these when we move forward. And then The consensus, as I mentioned earlier, what is consensus is? Consensus is the process of keeping ledger transactions synchronized across network. And so these are the key features that we have in Hyperledger Fabric model. Uh, so let's talk about what is smart contract is. Prior moving to the what is blockchain network is. In the blockchain network side, I'll show you. I'll tell you what is a blockchain network, how to spin up it from scratch. But yeah, it's better to get an idea what is smart contract actually is, and what we can get out of it. A smart contract, or what Fabric actually calls it, chain code, as I mentioned to you earlier in this slide. And as a trusted distributed application, it's actually an application which gains its security trust from the blockchain and the underlying consensus among peers. It is actually the business logic of blockchain application, which we actually write the code. There are actually three key points that I apply to smart contracts when, especially when applied to a platform. Uh, Actually, there can be many smart contracts at a one time running concurrently in a network. So there can be a smart contract for a user identity, and this is what we have done. Actually, we have two smart contracts running concurrently in the network. We have the smart contract to handle the identities of the platform, and then to do the identity verification. That part we are using that smart contract. So we have logistic network which actually handles this logistic orders. So prior performing the state persistence, it actually connects with the identity contract and do the verification. Then moving forward, it's like it's similar to what we have in Nimble as well. So if you take a look at the services that we have in Nimble, first we are getting the token and we are checking whether this token has the roles that we require, and then we are performing the we are going through the functionality and then doing the persistence. We are getting the data from the database. So it's actually somewhat similar. So we can actually map it that way so you can get a better idea when moving forward. So also the smart contracts follows an odd execute architecture in with the consensus protocol that we provide. It also validates and orders the transaction, then propagate them to all peer nodes. As I mentioned you in the start of the what is actually blockchain is. So first transaction will come here and do the verification by all the peers. If it looks like okay, then it will propagate the transaction to all the other peers that we have in the network. So one transaction will come and it will do the state change, and it will sync as soon as possible to the other state of the other state, I mean other databases, like other databases that we have in other peers. So that is what actually a smart contract is. And as I mentioned in Fabric, they do the transaction propagation to all the peer nodes, and then peers execute the transactions equally. Then I want to talk a little bit more about this Fabric model. What is an asset? Asset actually can range from tangible real estate and hardware to intangible uh, contracts, the contracts between two parties and intellectual property. This actually can vary from that range. A Hyperledger Fabric provides the ability to modify assets using chain code transactions. So you can do the time to time, you can do the changes. Like in our process, we are changing the custodian from one step to another. When we go in the logistic process, from like let's say we have these four steps in the logistic process. When we dispatch for the first time, we'll just persist on the blockchain. When we get event, when it's in the delivery, then what we do is we kind of change the custodian to the delivery person at the moment, and also the current location. So this kind of possibilities there, so you can actually do this kind of modification in the blockchain through the chain code transaction. But still, all these data will be uh, persisted there. You won't be able to change the history of it. So anyone should be able to view the whole the process during one step to another. So that's kind of a great advantage as well. So assets actually are represented in Hyperledger Fabric as a collection of key value pairs. There's a reason for this because in Fabric, we actually use CouchDB as a database. Actually, CouchDB is kind of a non-SQL database, which is kind of maintains key value pairs, and list of objects as it is. So when I'm going through the code itself, I'll show you what it does it mean, what is a list, and how they do manage the single objects set of objects inside a list as well. So assets are actually represented in Hyperledger Fabric as a collection of key value pairs. Yeah, that's what an asset is. So chain code that actually is software defining an asset or assets. It's actually the smart contract and the transaction instruction for modifying the asset. As I mentioned earlier, we are modifying the asset time to time when we are going through the logistic process. So from that, we are getting the visibility. In the other words, if the business logic chain code actually enforces the rules for reading or altering key value pairs or other state database information, and chain code function executes against the ledger's current state database and are initiated through transaction proposal. Chain code execution result is in a set of key value writes. So as I mentioned you earlier, assets actually finally from the chain code we are giving a set of list of assets. So this is what a chain code is. And ledger features, the ledger is the sequence tamper resistant. So as I mentioned you earlier, we can see the whole history. uh, Anyone cannot come to the blockchain and do the tampering stuff because we are keeping track of all ledger data which are submitted previously to the network, and also we have replication in each and every partner who is involved in this process as well. So it's tamper resistant of all state transitions in Fabric. State transitions are a result of chain code information invocation. So state from one state to another state uh, can be changed only by a transaction which we are performing through the chain code, and it's actually should be a transaction by the participating parties who actually we are keeping track of with the identities that we have, and the and also these parties who are involved in this process can connect to the ledger and do the modifications, deletion, or updates to the different kind of transactions that they are performing. Uh, from the privacy side, Hyperledger Fabric employs an immutable ledger. So immutable ledger is there. So this is the main reason why there no one can tamper the Hyperledger state database on a per channel basis. So what is channel? I'll let you know. Channel is something like uh, Docker network for now, let's say. So inside Docker network, we can do some sort of a differentiation. So if you have two Docker networks inside one machine, you can have the same containers running on both networks without interfering with each other. So it's something like that. Channel is something that you can define all your smart contracts, and in another channel you can define set of another smart contracts. They won't interact with each other. There's a way to interact with each other as well, but basically they won't interact with each other. They'll work on their own state changing process and do their business process, and this kind of will happen. So this kind of privacy we can again get from Hyperledger Fabric. A ledger actually exists in the scope of a channel. So as I mentioned, for a channel we have a database a ledger. Ledger is the database or the world state of the data, world state of the blockchain, where we store all the related data for a transaction, for an identity, for the assets that we are dealing with. Next, the consensus, the process of keeping the ledger transactions synchronized across the network, and to ensure that ledger update only when transactions are approved by appropriate participants, and that when ledgers do update, the update with the same transaction in same order is called consensus. So this is kind of a very useful keyword as well. So consensus, make sure to get the approval of all the peers involved uh, uh, in this whole process. Also, it will do the transaction if someone do a transaction according to let's say in the banking sector, if someone we actually need kind of uh, order in bank sector. If someone is getting money out or just depositing some money, so that we actually need, when you are doing the scale code as well, we are doing kind of, we actually need some sort of order there. It actually happens with the consensus protocols which are provided by Hyperledger Fabric. So it's very useful for any sector. So as you can see, we are keeping track of previous transactions as well. So the state will be always same in the all peers and peer states which are maintained throughout the whole network. So that's more or less about what are the features the framework that we are using, Hyperledger Fabric, provides for us. And I'll talk a little bit more about the what is blockchain network is. So a blockchain network is a kind of technically infrastructure that provides ledger. Ledger means the database for you, and smart contract. Smart contract is kind of controllers that we have inside, and which is packaged smart contracts which are packaged as chain code. So as you can remember, chain code is the smart contract, but in chain code there can be multiple smart contracts in Fabric services to application. So primarily smart contracts are used to generate transactions which are subsequently distributed to every peer node in the network, where they are immutably record on their copy of the ledger. So smart contract, as I mentioned previously, will help you to sync the records that we are persisting in a ledger of one peer to sync to all other peers that we have. Uh, the users of the application might be end users using client applications. So we have set of client applications which are uh, which, we have kind of integrations. We also have a client application which actually interacts with the logistic contracts. So there can be we can maintain set of identities on the client side. These are called wallets. Wallets are basically set of certificates, trusted certificates which are generated by the certificate authorities in the network in order for your identity to connect with the logistic contract to perform operations and to expose these operations to outside world. In most cases, multiple organizations can come together to form a channel. So yes, in our case as well, we thought of using two channels. We have Nimble, we have multiple organizations in our channel. So we have Nimble as well as EFPF as the two organizations. And also the transactions are involved on chain codes, and where permissions are determined by a set of policies that are agreed to when the channel is originally configured. Moreover, policies can change over time subject to the agreement of the organization. So in order for some transaction to do if in order to submit a transaction, there is actually endorsement policies which says whose approval we need. As I said earlier, we need approval of all of these. That's right. that's the default way, that's the default policy that we have. But we can configure, okay, if I want to submit a transaction to this peer, okay, I can say the endorser only will be me. Let's say this is Nimble, and only Nimble needs to do uh, the verification. Then in the endorsement policy, we can say, okay, we only need the verification from Nimble. We don't need any verification from the other parties. There can be times like that, but then the usage of blockchain will go away, because we actually require a ledger, distributed ledger, where we can perform transaction together with the verification of all these people. So you can define the enforcement policy based on the requirement. You can say, otherwise you can say, okay, we need two of these peers verification in order to proceed and submit a transaction to this network, to this peer. We don't need all of these. So somewhat similar like this, these are called policies, endorsement policies in Hyperledger Fabric network. As I mentioned earlier, for the implementation of the use case, we first consider both Hyperledger Sawtooth and Fabric. Finally, thought it may be good to use Fabric. As you saw, it has most of the features that we require in order to proceed uh, with our uh, use case. So the first step of creating a network or channel is to agree and define the configuration. The channel configuration has to be agreed by organizations involved in, and is contained and in an unchangeable block known as configuration block. So there's a, when we set up the network, there's a block called configuration block, which cannot be changed in any way. So we have to define a channel on the first phase and say, okay, we need this sort of configuration, these sort of endorsement policies in order to start the channel and to join the channel. So yes, a channel, as I mentioned earlier, it's like Docker network. It actually exists, logically exists. So there's kind of logical separation between channels, which will help you to maintain two separate channels in one instance or one machine as well. So all these definitions for the organizations which are involved in the for the organizations, for the peers, organization peers, and for the orderers, and for the database states that we are maintaining as well, should be defined by certificate authorities. So we have to actually, if we are building a network from the scratch, we have to define all these certificate authorities, and we have to do a lot of configuration work in order to identify each and every component which is related to Fabric network. But yeah, there are some tools nowadays we can spin up Fabric network for any sort of use case, from uh, for to for a prototyping, or whether you want a distributed network, you can spin up networks with these tools nowadays. It's what, as I mentioned earlier to Felix yesterday, it's somewhat similar in Kubernetes. We have in first times in first days of earlier days of Kubernetes, to set up a Kubernetes cluster, it will take like 2 or 3 days. But nowadays we have set up tools where we can spin up Kubernetes network as soon as possible within a few minutes with these tools. So it's similar to Hyperledger Fabric as well. I think it's because of these two technologies both are hosted by the same organization. So yeah, there are a lot of different kind of tools we can use to create the blockchain network now. So as I mentioned, the certificate authorities. What is this certificate authority? Actually, it plays a key role in the network, because they dispense keys, actually certificates, X509 certificates that can be used to identify components as belonging to an organization. Certificate issued by certificate authorities also can be used to sign transaction to indicate that an organization endorses the transaction result. A precondition it been accepted into the ledger. So that's what certificate authority is. So certificate authorities primary work is to issue you certificates to different components which are in the network to verify their identity. So now let's have a look. Since we have an idea what a smart contract is, now let's have a look at what are the smart contracts that we have. And yeah, prior to that, I think it's better to know what is actually peer is. Yeah, a peer in blockchain network is a compromised primary set of peer nodes. There can be actually one or more than one peers for an organization. In our case, also we are defining two peers for a particular organization. So they are like the nodes, simply peer nodes, where we have for each peer that we define for an organization, there's also actually one state database maintained inside them. So uh, peers are actually fundamental elements of the network. They host ledgers, smart contracts, and also, yeah, they are the kind of the main sort of pillar in the network. Yes. Uh, Next, another thing would be yeah, let's look at the smart contract and workflows. Then I'll show you these policies and let you know what are the policies actually as well. But first, let's look at smart contracts that we have defined for this particular use case. So we have a chain code defined with as I mentioned you earlier, we have two smart contracts in this chain code. We have uh, we have uh, okay in the chain code that it actually includes two smart contracts both communicating with each other, as I mentioned earlier. The logistic contract, which actually handles the logistic process of a dispatch order from the business process service, and then we have identity contract, which manages identities of the platform users from peer organizations. So it will manage identities for people who are coming to Nimble and from EFPF. So we are doing kind of identity persistence as well as, and we are keeping track of the user database separately in the blockchain as well. So in case we don't have to interact with Keycloak in order to identify the identity. So in that case, we actually have a state maintained inside the blockchain of the users registered to Nimble platform as well. So there are a set of predefined roles in Nimble that are used in chain code as well. Likewise, in our other services, we actually use these roles that we have in Nimble in order to proceed with some of the operations that we have defined in smart contracts. So we have platform manager, we have Nimble user, we have publisher, we have purchaser. So as you all might know, the platform manager is the owner of the platform. He has sort of all the access to our platform related stuff. And Nimble use is the normal with the least accessibility to the platform. The publisher is someone who can publish a service or product to the Nimble platform, and the purchaser is actually one who can purchase from the Nimble platform itself. So in the logistic contract, I just want to go into the workflow, then go to the code base. Uh, it actually defines the functionality for a dispatch order from manufacturer's end traverse through the logistic workflow according to the provided template that we showed in the start. The template that we provided from the Hollywood client. If you have a different production template, that's also fine. Since because you'll be sending the clients, the parties who are involved in this process will be sending related information time to time in their from their premises. So you can define your own business process templates and upload it during the negotiation process in Nimble. So only the identities with publisher role can publish and start a logistic process because they are doing the dispatching of the order, so they can start the logistic process. Right, that they can come into an agreement. Okay, these are the people who are involved in our logistic process, and then the publisher actually can start the process. Uh, to start a logistic process, the publisher should provide a list of organizations involved in the process. All organizations and the users involved in the process need to be part of either Nimble or EFPF platform and should have been redirected. If you are from EFPF, you should have been redirected to Nimble priorly. So we are creating identity for you in Nimble platform from our side if you are not part of Nimble at the moment. So once a logistic process starts, the users involved in the logistic process can change the custodian current location and exact time of the current purchase order. The users can only retrieve data from the ledger that is related to a logistic process. So the users, they should be actually changed to the users who are part of uh, logistic process can only retrieve data from the ledger that is related to a logistic process. So as I mentioned you earlier, the publisher and the service provider and the client buyer should come into an agreement and say, okay, these are the list of organizations which are involved in the logistic process, and we should have them registered in our platform. So these all people who the publisher has this defined in the start of the process can only retrieve data from the ledger related to a specific process. The logistic process from the ledger can be deleted only by platform owners since once it's requested by the stakeholders who are involved in this process. So this we are not giving access to the delete endpoint to other users or to the people who are involved in this process because uh, this is something that one party cannot do when they come they have to come into a agreement. Okay, we are not going to proceed, then they can request from the platform owners in order to delete the logistic process. This can be only done with a request by them, only by the platform owners. Identity contract flow also, so as I mentioned earlier, this will help us to manage the identities of users registered in both EFPF and Nimble platform, but they should have redirected to Nimble platform because we are providing this service through the Nimble platform, based platform itself. These identities are used in the case of data loss to recreate the certificates required for blockchain client to connect with the chain code. So basically, as I showed you earlier, there should be some sort of identity managed in Hyperledger client side. These are called wallets. So wallets basically are a set of certificates which helps us to identify the person who connects to the Nimble network, which will give you some sort of separation as well. But either way, we are giving another manual authorization process. We are doing authorization process, authentication process as well. Uh, but yet there are identities that manage on the Hyperledger client side, which are called wallets, which have set of certificates and helps you to identify the identities who are involved in this process. In case of data loss, I mean, if let's say if we in case we lost all data on the network and all the states are gone in our normal deployment in Nimble platform that we are using Docker volumes in order to maintain the states of the databases that we have there. In any case, we have volumes still persisted because we are using file-based volumes for Docker-based deployments that we have. Likewise, we can do the disaster recovery and again create the databases that we require. Likewise, in this case, we need to recreate the identities which are involved in this process. In that case, we need to create this to maintain these identities in a database. This is another reason why we actually thought of maintaining a separate identity database identity state inside blockchain as well. So in the blockchain network that we are going to implement that as well. So that's about it. And one identity has the roles attached to it similar to Nimble, which are same as Nimble platform. Only users themselves and the platform managers can delete the identities. This is somewhat similar to what we follows in Nimble platform, either them or the platform manager. When they request from the platform managers, they can delete themselves from the platform. Only the identity is registered to the platform can perform operations defined in the logistic contract. So if you are only a part of the platform and if you are only a part of, and if you are already a part of the state that we are maintaining inside the blockchain network, then you can perform the logistic contract. So we are doing kind of auth process inside the smart contracts. That's what we say here. So we are checking whether you are persisted inside the blockchain as well. So there's kind of authentication layer in there as well. So in the start of the logistic process, the list of parties involved in a particular logistic process should be defined. The identities of these parties can interact with the logistic contract and perform actions. Now, so it is mandatory for these identities to have defined roles as well. And this contract, as I mentioned earlier, it's highly coupled with the logistic contract as it helps logistic contract to verify the identities of the people who are calling to the smart contract in order to perform an action. So first we are doing verification of the identity. It's similar to what we have in Nimble. First we are doing from the token that we get, we are doing okay, we are checking okay, what is the identity of that person, what is the role he has, then only we are following and doing the other actions. So it's similar to that. We are following the same workflow in here as well. So now I'll walk you through with the smart contract implementation that we have, and it's better if I use it here. Okay. So this is the smart contract repository that we have. We found a potential one. So we get a okay. So there's some dependent bot alert. We can fix it with pull request, so I'll fix that afterwards. But let's look at the repository structure. So I have defined the things that I have mentioned to you earlier, as well as what are the workflows and what is the contract and how to test this on the test network. So what is test network again? Test network is a fabric test network. So you can easily spin up a fabric test network without any work. So it's just with this network sh shell file, you just have to execute that and it will deploy a test network inside your machine. And also you can deploy a smart contract, and how to deploy that and to test things I have defined it here. You can go one by one and try to verify things, but with the deployment tool that we have used, it's really easy as well. Like you don't need to use the test network anymore. You can use it. You can do local deployment with the tool that we have defined, and then you can do the testing as well. And also I have mentioned some of the key features that we have defined, so I'll show you them when I'm going through the code. So now I'll go to the code base. First, I want to have a look at the package JSON. I want to look at two of the most important one, the contract API and the Fabric Shim third-party tools. These are like the SDKs which are provided, which kind of provide us the ability to interact with the Fabric network. They give some sort of abstraction for us with these third-party tools to third-party libraries, so we can easily use this in order to do our work. So these two is very important if you are in a Fabric contract project, and others like this are used for unit testing and stuff to do other sort of things. So these two are the main things. But before going to this one, this project actually was generated. This basic template of the project is actually generated using a Yeoman generator. So I'll okay. This is something uh, which was backed by IBM blockchain team, which helps us to generate the basic template. So this is basically, if you have heard about Yeoman, Yeoman has a lot of templates for you for different sort of projects, for Angular projects, for Java projects. It's similar to what we are doing in Spring Cloud projects, Spring Boot projects. There's a website for Spring Boot where you can go there and define the name of your project and define the set of libraries that you need, and you can then download it as the skeleton of your project. So this is somewhat similar that we have done. So you have the step-by-step guide how to use it. So we have made the smart logistic smart contract, and we have initialized it, so it gives us what are the basic third-party libraries that we need, as well as the basic index files that we require to use. So this is the generator that we use. This is actually somewhat good, and we thought of moving forward with this, because this actually, the people who are involved in this are also uh, involved heavily with the high pleasure organizations as well. So we thought of going forward and generating the templates with this one. So that's it about the Fabric generator. So I have come up with something like this, and I came up with more modified way in order to maintain my code base as well. So first, I want to give sort of an idea about um, the abstraction that we have used. So we have smart contracts which are written from Fabric Contract API 2.0, as you saw in the package JSON here, and in here, and common operations which are required to any use case are separated out, uh, which helps other developers in order to perform and write their own smart contracts. So this will be like the data persistence layer in your application. So this will have all the related information, like in data persistence layer. What we do sort of adding to the database, we do querying from the database, we do get history, likewise related operation which actually talks with the hyperledger state ledger actually are separated out for you, so you can easily take out your smart contract business workflows to another simple project like to a control like this, and you can interact with these two state operation defined files, and you can perform all the Hyperledger Fabric based API operations. So what are these two state and state list is in state .ts. So this is written from again, this project is written from TypeScript. It's Node.js, but we used TypeScript because it will be easy for most of us, because it's more type safe, as well as it's like we can use most of the object oriented paradigm things TypeScript, if other than if we use in JavaScript. So it's kind of similar to what we write in Java again. So I'll show you when we come to that places. So we have different sort of annotations which will define things, and we are using uh, set of features which provides by the object-oriented paradigm. So so what happens in the state class, state.ts class, it will define common operations for supported class type that are useful for a state for a single instance. So like if you want to serialize an object, if you want to deserialize an object, if you want to make a key for an object, if you want to split key for an object, if you want to do these kind of operations, all the related operations are defined in the state class. And as I previously mentioned, we are maintaining the state of the assets as list. So we have to define list-based operations. So list-based operations are defined. All the list-based operations are defined here, which gives you kind of generic way in order to define a list of assets that you are maintaining inside the blockchain. So this is somewhat similar in Java. We have the generic type, and it can extend the state type. So the state is what I showed you earlier. So it can have the operations. If some object is extending state type, it can have all the operations which are defined here. Likewise, to the state list, we are providing objects which actually extends state. For an example, I'll show you one of the models that we are using here. So so this is the asset, the base type. So we use order type as the model to persist all our order details. So it actually extends asset type. So asset type again extends the state type. Asset type is the base type. So I used it because for orders and items I use for both I use asset types, and it actually extends state, and so it can be provided as a generic type to the stateless class. Stateless class here. So again, coming to here, what are the operations based on for list-based operations to add a new object uh, to the state, to get a specific object from the state, to get history, to read the history, to get all related all persisted operations transactions from the state, from the ledger, count number of things, to update a ledger, update the ledger, to delete the ledger, to check whether object exists inside the list, to query things. So basically, uh, in as I mentioned earlier, in NoSQL databases, we are maintaining lists. So it's about maintaining set of list, and inside list we have single persistent objects, and it's similar to something like that. So from this query option, we can get a lot of work done. So you can do query similar queries to CouchDB that you do in CouchDB. The query can be done like that. So I have found some very interesting articles on this as well. I'll show you. So this is something written by one of the people, but I found it very interesting because it gives you set of queries where you can execute in CouchDB, which means we can execute them on Fabric as well, because in Fabric they're using CouchDB as a database, and for querying as well, they're using the CouchDB based queries. So we can exactly use the same queries defined in here in order to interact with the database, which is backed in Fabric. So I found this article very handy, and I got a lot of usage from it. I'll show you when we come to the smart contract how I have used them as well. So that's about the state list. So this has all the operations that you want in your smart contract to maintain the list, asset list that you want, to add the list and get list likewise. and state has single operation, single instance based operation operations that you want. So this is kind of an abstraction that we are giving to developers. This is kind of extendability that we are giving to other people, so they can use these state and state list classes and define their own contracts. So I'll go to the two contract classes now, and first I have defined a base contract again, and I'm extending the contract object type of fabric contract here. And what happens is I have two another contracts. So I have identity contract, as I mentioned you earlier, so I'm extending the base contract that we have defined here in this. So next I have this transaction annotation going on. We actually need this will say, okay, this is a transaction which changes states of the world state of the blockchain. And also like in our controllers, we actually have, okay, in our controllers we say, okay, what we are going to return to the end users. Similarly, we can say, okay, what is the object type that we are going to return to the end users. So if I go through this controller, this is the smart contract, the identity smart contract. So I'll go through one by one. So init identity ledger. So this is somewhat we require in the first phase. When we deploy this smart contract to the blockchain network for the first time, we actually have to initialize the smart contract first with some mock values, and initialize the state, initialize the database, append, initialize the list which persisted inside the NoSQL database. So we need kind of initialization function which helps us to do that initialization part. So this is the init function. Somehow you have to do the initialization of the list that you have inside your application. So this functionality is required. So we are using a mock objects where we have defined in a separate file for our usage for the initialization phase. So we have defined user mock, and we have defined order mock, where we used to initialize these states in the blockchain for the first time because it's required. So going to the next function, in here I'm trying to create a new identity. It's about creating a new user in the database, in the blockchain database. What I'm doing is first I'm checking whether this identity actually exists in the database. Otherwise, if it's not, then I'm going to add this user to the database itself. This is also a transaction, an asynchronous transaction. So yeah, finally I'm returning the user after we add them. So first I'm checking whether we have this user exists. If not, then I'm adding him to the user list. So you might think about this context. So this nimble context is this CTX that we're using here. CTX is like context. It's like something that we initialize for the first time. So in there we load, if you have data in the ledger already, we load the list of data to this context, or if not, we are creating these objects. So it's like in Spring Boot we do kind of DI dependency injection. For the first time we are setting, if you want to set set of objects where we are using as singletons throughout the whole project. We have to do kind of set of configuration where we can identify what are the object types that we're going to resolve when you call the DI part. So in that case, we have to define the context by ourselves. So I have defined the context. I'll show you the context by moving towards, because in here you can see context user list I have used. So you might think, okay, where is this user list is coming from? So I'll give you kind of an idea. Okay, so this is the context file we actually first defined. This will be up and running for the first time when the application starts, when the contract starts. So in there I have defined three read-only properties, which are related to order list, or the party list, or the user list that I'll be using throughout the whole project in different set of smart contracts. So I need to refer this when I'm writing the smart contract, so I have to define a way to create the singleton objects of this list. So that is what actually happens here. Also, I'm giving kind of what is the object type that we can use inside this list. In asset list, I'm using set of orders. In part list, I'm using set of parties. Parties are companies in the context. In user list, I'm using set of users. So you can see the user list actually again extends state list with the object type user. So state list is the place that we define all the list based operations. So what happens is user list will extend state list with the user type object, so it will get all the operations defined in the state list as it is. So this is somewhat similar what we are doing in Java as well when we want to define we want to get the usage of inheritance and generics. So it's somewhat similar, so you can have an idea. So I have defined the context, and inside context I have this party list, this user list, this asset list, and I'm initializing them for the first time in the context inside the context.ts file. So now I can use this Nimble logistic context. We'll go back to the place that we started. So I can use the Nimble logistic context. So from the start of the project, it will create the context for you, and you can actually interact with that. That is the list that you are maintaining inside the database. So you can actually add user to that, and you can change whatever you want and update to that. So this is what actually we are doing from the list that we are defining here. So to create a new identity, as I mentioned, I'm checking whether we have any identity existence with the provided details. If it's not, I'm persisting it. And the next thing is changing the custodian, because time to time when you go from one business process step to another one, then we have to change the custodian of the change the okay. Give me a second. Yeah, custodian of change the organization of the sorry. It's about change the organization of the identity, because there can be places. I thought maybe there can be places like one person who was part of one organization can change the identity of the organization. So I added a kind of functionality to do that as well, to give some sort of change to the organization of the identity as well. So first I'm checking whether use actually exists. So you can do it easily with the get functionally defined in the state list class. So user list is something extends state list class, and you can use the functional used there. So with the user ID, you can get the user, and you can check whether this user is defined, whether there's a user that we have, and also we only give the ability for the platform managers to perform this action. So only platform managers by themselves only can perform this action. So you have to pass the user email of the person who is doing this change as well, apart from the user ID of the actual user who is going to change the organization. So we are checking from the user email who is this person, whether this person is a platform manager or not. If it's a platform manager, then we are updating the user's organization. And next one is a simple get identity, and it's also transaction. Then we are returning a use object. It will give you a specific user when you provide the user ID. And then the delete identity, this also can be performed by platform admins only. If it's the user is platform admin, then if it's the platform admin platform manager, then he can delete the user from the use list. Next is if you want to check whether the user actually exists. So these kind of operations are already we require these things in some sort of places. We want to check whether this user exists in the logistic contract sometimes. So we have endpoints like this. And also if you want to query the user by the email, we actually give some sort of ability. So this is the place that I said that we can use the similar queries that we can use in CouchDB. So it's this query is somewhat similar to what we use in CouchDB. I can show you more stuff on the other part as well, but yes, this is somewhat similar to what we query in CouchDB. We can see what is the selector, and the selector is the email. It's similar to the name of the parameter that we are passing, as well as this attribute. Be this attribute name should be the same. So it will look at because if you go inside user object, you can see the email here. So it's the name is actually similar from what we are referencing. So I'll go back here. So it try to query the user with the email that we are providing. So if user exists, we are sending back. Otherwise, we are sending the user back. And check identity existence. Again, we are using from this is somewhat actually we require in logistic contracts as well. We are checking whether the uses exist inside the context, inside the list that we have. So that is about the identity contract that we have. It basically helps you to identify a person and to create a new identity, change the organization, to query identity by email address. So these sort of identity related operations are as normal as in identity service that provides. So it's quite similar to what an identity service provides. So we are doing this inside the blockchain network as well, because we want to keep track of the set of users who are used in this process. Then I'll move into the logistic contract, where we actually persist the orders. And here also we have the init ledger. As I mentioned earlier, we need a function where we can call from outside to initialize the state, to initialize the database as well. So we are using the init ledger function. Also, for one chain code, there's a problem I faced when it comes to this initialization. For one chain code, you can do one initialization. So what I did was I tried to initialize both user list and order list from here without calling the init identity ledger function in this identity smart contract. So apart from that start logistic process, so what happens, as I mentioned to you earlier, we have a separate layer of authentication here. We are getting the user email from the client. The client is actually the blockchain client, and it's also another separate project. I'll go through that as well. So in there we are doing token introspection as well as token. We are decoding token, and we are checking the roles. What are the actual roles for these set of endpoints that we require, because there are endpoints which maps there are actually endpoints which maps with the smart contracts. Each and every function is defined here. So to enter this function, what are the roles that we required? So we'll be checking whether the user that has sent the token has the specific roles defined before sending the request to the smart contract from there as well. And after coming here from the user email that we get, we are checking whether this user has a role publisher, because we are maintaining this user's roles again inside the blockchain network as well. So if he has publisher role, okay, then he can start the logistic process. And next, changing the custodian from one step to another. So there are set of defined logistic processes, and there can be more from by going from one to another. You can change the custodian of the transaction time to time. So this endpoint will help you to change the custodian. And something that we have to look into here is we are checking because there should be an order started already, and we are trying to get that order, because now we are trying to change the custodian of that order, and we are trying to check the users, get the user from the provided user email. And also we are trying to check whether the order has something called involved parties. This is kind of an attribute that we are maintaining, because as I mentioned earlier, when publisher is the person who create the product, or publishes a service. When he dispatches it, he has to come into some sort of agreement with the parties who are involved in the logistic process that he knows with the client, and they have to define the set of, he has to define the set of parties who are involved in this process. So what we are doing is, if a request comes to change the custodian of a current event, what we're doing is we are checking whether that use actually exists in that involved parties that the publisher has defined. So in that case, if the use actually exists, then we are changing the custodian of the order. So next one is to get a simple order to get related data from order, and the next one is to delete order. Then here you can delete order, so you can only the platform managers do the deletion of the order, and to check order exists. Yeah, we can. Only in this part we are just doing a query and just giving kind of a boolean whether it actually, we are not doing a transaction, we are just trying to read the ledger, and from one state, I mean we are not reading all the transaction databases that we have in all peers, but when you say transaction false, it will just read one replica and say okay, this order exists. And retrieve order by party, yeah, you can retrieve set of orders which are related to a one organization. So this is somewhat helpful for us to showcase what are the logistic orders going in for an organization from the Nimble platform front end for a party. So we are exposing this endpoint, which will give you kind of an idea of what are the actual um, who are the actual parties involved in this process. What are the orders for a party? Because in Nimble platform, for particular use, if you log into Nimble platform, there will be a party ID for sure. So from that we can query this and get related orders for that organization going on, and show some sort of logistic kind of visualization, which was actually previously done already, and by University of Bremen on their use case, we can reuse that similar thing as well. And retrieve order by user email. So you can even retrieve orders by user's email. So okay, I just wanted to show something again. Here we have used the CouchDB queries. So I'll go back again to the um, to this one that I'm showing you. So it's actually the same. Because it is blockchain, it doesn't mean there's a separate coding language that we have to use. It's actually the same. So here what I'm trying to do is I'm trying to check whether the party ID that we are getting is actually inside the involved parties of the order that we are getting, that we are having. If from the order list we are querying the all orders and checking the involved parties attribute, whether we have the party ID inside that. So it's similar to this query in CouchDB, with in that case they tries to go to a marbles attribute and check the color is inside in red or green to get set of objects that they need. So it's somewhat similar, not it's actually the same. So you can do these sort of querying from the fabric as well. It's actually not, there's no specific querying language only for blockchain. It's the same. It's the CouchDB database. So as I mentioned previously, we have to retrieve order by user email, and It will give a list of orders based on the user's email, and this will help us as well in order to define the UI workflows as well. Uh, so I have defined another endpoint retrieve orders company of the current user is the custodian by email. So uh, to get to get if someone is holding the product at the moment of the logistic process, if someone is the custodian of the logistic process, there's an endpoint we are exposing just by providing the email of that user. You can see what are the orders and what are the logistic process, and also at the moment the custodian, that person is custodian, and you can show the orders uh, which are uh, which are related to the logistic process. So that's it about the two smart contracts that we have written. It's actually somewhat similar to what we are writing in normal day by day. The only difference is we actually have this thing. We have this separation of the DTO layer, data persistent layer, which is actually the part that interacts with blockchain. So it's just about writing your own business logic, which will help you to achieve the business targets of your use case. So it's something like that. There's quite a good kind of separation in here. So I'll go through set of models that we're using. So I said we have a base class called asset, and I extend state, and we have order which extend asset. Then we have all the related details that we are getting from EPC events that we get, and from the dispatch order we are getting. So we'll be sticking to this model, and time to time we are changing this order details when we get update event from APC events that we get. And order details is set of attributes we have seen on the EPC events. And on the config side, okay. So this will be the logs that I thought maybe it's good to push to the log stash. I wrote sort of a login function which will push uh, or not in the client side. This is just a normal log which will be on the container side. So yes, and on the user identity side, we are also again extending the state type, and on the party as well, we are again extend identity type, and we are maintaining the party HCID as well. So in user type, we are maintaining all related attributes which we need: party ID in Nimble, party name in Nimble, the roles in Nimble that they have. So we can actually do some sort of operations or that will actually syncs with our Nimble instance as well. So we are maintaining separate database, I can say, with the actual data that we have in Nimble. In location, I'm taking these set of details which will be there on the logistic process: location identifier, city, region, postal name, building names. This will be coming through coming for the first time when you do a negotiation. So you can see, if you go to Nimble platform and start negotiation process, then you can see we have to enter these things: location, city name, region, postal zone, when you want to dispatch an order and start the logistic process. So it's kind of it's actually the similar, and I'm trying to keep track of that things for an order as well. So that these are the models that I have used. And yeah, apart from that, there's an annotation that I have created which will say not required, because there are no annotation at the moment which will help us to make an attribute in a model not required. So we created a custom one, and it's in there at the moment. And we have exception class defined by us, which will help us to identify the separate exceptions related to the Nimble contract exceptions. So this is the smart contract project that we have come up with. And next I'll show you how to deploy this as well, and how to expose this as well. So I showed you the two contract workflows that we have defined, and next we talked about these things as well. Uh, it's possible to extend the smart contracts for the use cases as you saw, and all the main functionality of Fabric required to perform transactions on the ledger are abstracted out in state and stateless classes, and the abstraction of ledger API. All smart contract operations are implemented using standard long-term support Hyperledger Fabric Contract API 2.0. So previously it was in they have a 1.4 and 1 series, but we thought of moving forward to the latest one because it has a long-term support now. And also someone should can ask why we went with TypeScript in order to write these smart contracts, because there is Java, because there was no much documentation in the SDKs that they provided on Java at the moment. When we were starting, there was actually no not much uh, not much support on Java side, so that's why we thought maybe it's a good idea to move forward with.
Yes, just a question in between. How much material have you got left, time-wise, approximately?
Time-wise, another 40 minutes.
Okay. Just question whether there's anybody who needs a desperate break, or whether we just carry on for the 30 minutes.
Yeah. So we'll take a break and then carry over.
No, just a question to everybody. 30 minutes okay to carry on?
Yeah, sure. I can show everything if you want in. Because I thought of doing a deployment of these and show you the demo as well. Okay. From the.
No, fine. Then let's carry on. Go on.
Yeah. So I was talking about this stuff and common collection operations in the ledger to add state, get state. We talked about this stuff in the code base as well, and I showed you what are defined in state and stateless classes. So I'll not be walking more again on this slide, but actually I want to point out that the smart contract will be the service layer which interacts with the data persistent layer defined in stateless class to maintain the burst state of blockchain ledger. This will help you to this actually helps us to give some sort of extendability to the smart contracts. So it's something that we should keep in mind, because there's all the required operations which are required to interact with the blockchain state is already defined. So if you want to write another new smart contract, you can use that and move forward with it. And data model also, I just went through from the code base itself. I'm not going to go through again, and also have defined extended contract schema as well for you to have a look. And now I'll be talking about the next part, next component. So this is again another project. So there are three components that we have to work on in order to, on the blockchain side, in order to achieve the task. So this is the blockchain client, and the gateway is this part, which actually exposes these endpoint, this functionality to outside world based on the identities, based on the identities that we have defined. It's about developing. Now I'm talking about the development of this Hyperledger client. So the REST API for the Nimble Logistic contract, under the cover, this will be the API gateway, which exposes the functionality of smart contracts, and a file system wallet is used to manage entities for interacting with the network at the moment. So there are a lot of type of wallets, but at the moment we're using file system wallet to manage our set of identities. A gateway to talk to the network is established by passing common connection profile, a specified identity, and the wallet that contains the identity. Once the gateway is established, you connect to the channels. So once you have the contract object, you can start invoking, querying the chain code. I'll show you what does this mean from the code base as well. So this is like a gateway which talks with the smart contract that we show, the functions that we show in smart contracts. So there is one-to-one map with the functions, with the controllers that we define in this client, and with the functions that we have defined in the smart contract as well. So I'll show you that as well. So the good part is good part about this is this application uses a custom module to dynamically create and mount middleware functions that connect to Fabric Gateway. This one is actually we actually found a generic implementation from Hyperledger of IBM blockchain team again. So I'll show you. So at the moment, this one is hosted in one of our servers. So I have documented the credentials for this for this instance as well. So I'll show you how to set up this in local instance with a demo now. But prior to that, I have to mention that this is something we actually got from we got from the IBM blockchain starter kit. So that this is sort of a skeleton again, but it gives some sort of more functionality than the smart contract skeleton. So this is again developed by IBM blockchain team. It's a smart, it's a starter kit, very useful and handy tool. They have already mentioned how to use this pack. I'm still on the call. I'm sorry.
Just sorry to interrupt you.
Yeah.
I will just wait for you. Is that okay?
Just a second. Just a second, Sigisi. I'll talk to him. Just a second. Sorry about that. I have a meeting scheduled with Sigi, and yes. We were talking about. So they have mentioned how to reuse this for other projects, and they have mentioned to reuse it for other purposes as well if you want to develop your own client gateways. So we move on and use this API Bootstrap a template by ourselves. We fork this and use this as a starter kit for our client. And if you go back again to our Logistic API, so I'll show you a few things on the Logistic API side. This is also again a Node.js project. This is written in JavaScript. So as you saw here, so here we expose a Swagger UI with all the endpoints that we have defined in smart contracts. So I'll show you what does that mean. But for the time being, we have open API spec defined here for each and every operation that we define in this project, and so it will be easy for the developers who are interacting with this to get an idea. So it's easy anyways, because we in all the projects that we have smart we have Swagger spec defined, so we thought of having that as a part of it as well. So so there are key things that I want to have a look here. The Fabric connection profile is the okay. Yeah, here we can define the set of routes, and there's sort of introspection we are doing for each and every route that we have defined in our Swagger paths, in our controllers, we are telling, okay, what is the, whether it's protected, this path is protected. So we are checking from the middleware, whether we are going inside the protected path. If it's enabled, okay, we are doing some sort of, we are checking for the token that is passed to these endpoints. If it's enabled false, then we are not checking that as well. And again, allowed clients, we have set of clients. This Nimble client is the one that we use to manage Nimble users, and eFactories client is the one that we are using in order to manage the eFactory, redirecting people from eFactory. So we are checking whether these tokens are issued from eFactories client or Nimble client. It's kind of an introspection, manual introspection done inside this inside our routes. And I'll give some sort of idea of these all configurations when we do the deployment, because currently these configs are empty. As you can see, these will be coming to that place when we are doing the deployment. So from the control side, we have two controllers, main controllers, which are specifically for the, this one is actually maps with the uh, I'll take this to two sides. Maybe we can have a look at like that. So this one actually maps with our smart contract, Logistic smart contract, which means with all the functional defined here. And this controller, set of controllers defined here will map with the identity contract defined here. So I'll go inside the business. So here we have create order. If we go inside create order controller, it's quite similar. It's like the controllers now, we are getting data from outside for these things. So it's quite similar to a controller in Java. So we are getting all the data related to perform operations from these endpoints. So what happens is I want to show some quick things here as well. So we are using Fabric Network as a third-party tool here, third-party library, which actually helps us to connect to the contracts on the backside of the application. So which means that the third-party library that I showed you will help actually for us to define the connection, establish the connection between here. So that is the usage of the libraries that Hyperledger provides us. So as I said, here we can directly connect to the contract through this. If the connection established previously, we can actually access the contract that we have deployed in the network like this. So the channel we are connecting to channel, my channel. I haven't changed that, but I will change that to a different channel name. But at the moment, the channel name is my channel. And if you go to the context here, you can see the network name that we are defining. It's the same network that we're using here. And we are connecting to this network that we have defined in the constant, and we are exposing this network name and network UID for the Fabric blockchain network. So we are using the same network name. And if you go inside the Logistic contract, in the constructor, we are sending what is this contract name as to the superclass of this, that means the base class, and again to the contract. We are saying this network name dot contract name if you want to connect this. So it's exactly the same what we are doing here. We are saying, okay, the network name we got from here, and then the contract name that we are passing from each and every child contracts when we try to initialize the objects of it. So we are passing the ID contract name as it is. So we'll try to connect to that one, and then we can access the functionality of it and submit the transaction. So we can get all the required data from the request body, and if you want to do some sort of verification, actually you can do the verification through I have used the Swagger spec in order to define the required and non-required stuff. So you can do it from there as well. In here, I haven't done any verification for now, but in Swagger spec, I have defined what are the required fields and not, so you don't have to worry about that in this place. So you can send as a string object. It's quite similar to what we do in an Angular client. So if you are trying to call a backend call, so we do JSON stringify with the object that we create, and we try to map. Now we have got the contract, the logistic contract, and we try to map, try to call the method, this method inside this contract. So it will map to this. Sorry, here. This method defined in here. So that is the one-to-one connection which will be established based on gRPC connection. So I'll let you I'll show you why we say it's gRPC connections, because we'll be creating a lot of gRPC configuration files in order to do this map this connection between controllers and the smart contract functionality. So I'll not go dig deep into each and every of this, because I showed you the create order functionality, and it's quite similar because I walked through the smart contract part, and I hope it help you to get an idea about the functionality that we have defined here. On the identity as well, it's the same. We have get user, delete user, so it will connect to the identity smart contract as you see here. And yes, that will define set of controllers endpoints for us, which we can contact with the smart contract defined in the backside. And we have some health and ping functions defined for us to invoke and see whether the smart contract is running or the project is running. So we have defined I have defined two endpoints which will do that part of the site for us to give kind of function like that. Yeah, that's about it. And here I want to show more about also we actually define all the unit tests and integration test in this case. And I okay, over to here. Let's go to latest. So if you go to smart contract, and here you can see all the unit tests are defined at the moment, and for each and every operation that we showed. And so we can integrate this easily with the Jenkins, but yet it's not integrated, these two projects. But we can easily add a Jenkins file and integrate it with our Jenkins CI/CD pipeline as well. That's possible. That's possible as well, but at the moment it's not. So that's it about the Logistic API. I can show you a few things, and all the documentation related to this Logistic API is also documented here. And a few other things that I want to show, maybe okay. So normally you have to define set of routes in a Node.js application. So we have used route folder. So if you want to define one route and map it with a controller, so you have to do it from here. So if someone is coming to this route, which is order route, and try to do a post, it will map to the controller defined in this create order class. And to get the order, it will go to get order class. So the mapping between the route and the controllers will be happening this place. So we have the route folder in order to perform that task. Yes. So this here we have few things that I wanted to show you as well. So when we start the project, first thing happens is the setup part. The setup will try to go through the
routes that we have defined, and one by one, as I showed you in previous config file, we can define whether it's a secured path or not. So it'll, if it's a secured path, it'll we are checking whether protected is enabled, and if it's enabled, then we are checking whether we have the allowed clients. We are doing the introspection here, and then we are trying to allow it and create. Then we push the routes to the we are publishing the routes after doing the authentication filtering, and then we are pushing the routes. And to set up the gateway with the smart contracts, what we are doing is we are not actually using IBM cloud environment things. We are just passing the administrative details of our own networks, because we are not using IBM cloud in order to do the deployment, because we are using our own instances in that case. This will help to initialize the wallets. Wallets are the entities which will help you to create the identity initialization between these two places. So so we are doing a kind of wallet initialization from this part and trying to connect to the wallet to the network with this setup gateway functionality. And yeah, that's almost it. And I wanted to show kind of deployment demo as well. So let's actually move to that part. So that's about the Logistic API that we have developed. I have covered these things, and what are the controllers, and from security, I'll talk a little bit about security. Apart from the ping and health endpoint, all endpoints we are using are secured. We are performing introspection based on the clients that for one endpoint that we have defined in the configurations. You can define protected paths in API config as well. Also, you can define allowed key clients, token issued from these clients can go through. Also, this was kind of interesting thing that we faced, that I faced when I'm working with it, because I got a lot of response saying, okay, chain code only can have only one smart contract, but finally we figured out we can have multiple contracts, and we can access both of them from one single client application, as well as we can package them as per one chain code as well. And these two smart contracts actually can work together in a single chain code as well. So these are some of the aspects that we actually try to follow, and we tried hard to follow the best practices when we are developing these two projects, the smart contracts and the blockchain client. So next, I want to talk about the deployment of the blockchain node. So I'll do kind of a deployment to showcase you how to do the deployment by yourself. And I have, and also I want to say we have the API Gateway Developer Guide, one step-by-step guide, and about what is it on the documentation portal as well. And then we have the deployment guide, step-by-step guide that I'm going to do now to actually host the smart contract and to expose the smart contract. So we have documented everything here as well, how to install chain code, how to approve it, commit it, initialize things, and do testing, and generate connection profiles. These things I have step-by-step guide. I have documented it in the documentation portal at the moment, and the smart contract developer guide. I have mentioned what I have mentioned in today's talk as well, in this place as well. So you can have a look at these things as well. So now let's give it a go and do some sort of node deployment in my local machine. So here I'm using tool called MiniFabric. Prior to that, I have to say what is MiniFabric is. For the deployment of the track and trace solution, we are using MiniFabric, a very handy tool developed by IBM blockchain team. So it's now inside Hyperledger Labs. You can find it inside Hyperledger Labs. So according to standards, they have renamed the master branch. That's fine. But this is the repository for the MiniFabric. It helps you to get some sort of an idea about what is how to spin up a fabric network as well. And if you want to deploy a multiple production grid server as well, it's possible with MiniFabric, and it's a quite handy tool. So we thought about using it. It's an open source project which is hosted that now by Hyperledger GitHub organization. So which means it has a good team backed it by, and it's from again IBM blockchain team. As I said, MiniFabric can stand up a fabric network on a small machine like virtual VM, but can also deploy fabric networks across multiple production grid servers as well. Also, MiniFabric has been tested on Linux OSs, Windows 10, and supported releases 1.4.4 or newer, which means it supports our use case as well, because we are using 2.0.0. So a few other key highlights that I want to show on the MiniFabric side. It will help to set up and expand network, and also expand by adding new organizations. It will help you to query, create join channels. It will help you to install chain codes, approve them, instantiate them. This is somewhat normal process that we have to do in Fabric also. They have written a very handy CLI tool which will help us to invoke this process without calling the Fabric third-party SDKs. So we just have to invoke the CLI tool which was exposed by them, and you can approve the chain codes. You can instantiate them, invoke them, and query them, even query them with the CLI that they are providing. Also, it provides node monitoring, health check, and discovery as well, and it will never pollute your environment. It's based on you can do multiple channel configuration if you want, and deploy several sort of smart contracts with this, because it will use the Docker networks support to differentiate the virtual to make the virtual differentiation between the channels, and they're using all the Docker Compose deployments, as well as they support Kubernetes as well very recently. So this is about the MiniFabric, and so we thought this is the best tool for TNT blockchain solution, because administrating a fabric network is a very time-consuming task. Because I went through that, it's like a lot of configurations. I gave up on that because I thought there may be some great tools which will help us to do the configuration. It can be done, but it's like writing a lot of configuration files, and like writing a lot of configuration file is very time-consuming, and it will take a lot of time as well. So we thought of using this one because it's the best solution nowadays. One of the best solutions nowadays, which are suggested by the Hyperledger organization in order to deploy the spin up the fabric networks. Defining different certificate authorities, different certificate requests for each and every component need to be done if you are doing it from scratch. MiniFabric is a very handy tool which actually helps to overcome the permission issues and set up fabric network, as I mentioned, within 5 minutes on your own. It already supports deployment of chain code as well, written in different languages, which is a very popular point for EFPF platform, because in the future there can be chain codes implemented in Java, Node.js, Python, etc. So you can develop your smart contracts by any language, but still you will be able to host it from the way that I'm going to showcase today. Okay, I'll do the deployment now. So First we have to download the minifabric file. To download the minifabric file, they have defined how to download the minifabric file. It's very easy. It's just one command, and you'll get some configuration like this, and it will be basically calling the services that they have defined, the repositories configuration that they have defined, and get all the containers into local machines or the machines that you are deploying, and do the deployment for you. So next up is the organizations that we want to define. We should be defining the spec YAML file. So the certificate authorities that we want for our organization. So we need one for our effective one, and we need the certificate authority for Nimble, and we need 2 peers for each organization, because we want to do some sort of a high availability, as well as we want to keep replication in at least two replications in one for one organization. And then the orderer, which actually syncs do the syncing part of transactions as well. And then you have to define the endpoint address. This is the public IP of my machine. So they will try to create the gRPC endpoints based on the endpoint that I defined here. And this will help us to do the client and smart contract integration very fast. So these are the set of configuration that we have to define on the spec YAML file. I have documented this as well in the documentation portal, and we can have a look at the Minifab CLI. So there are a lot of options that they are providing for us. So I'm going to bring up the network. So here I'm trying to bring up the network, and I'm saying the organization which start this process is EFPF.com, and I want to expose the these outputs of smart contract to outside, because I want to my client is running separately, and it's trying to connect to the smart contract from outside. And my database that I'm using is CouchDB. You can use LevelDB as well, which is the default database. It's like H2 database, in-memory database in Java. But if you don't define any database here, you'll be end up with LevelDB. Then the querying part that I showed you in smart contracts will not work. The query part and more complex queries can be done only with, if you move forward with CouchDB. The LevelDB will not work for you if you want to have that sort of complex queries. So I'm trying to up that now. So it will create my channel. This is my channel, and the database type is CouchDB. And for now, chain code is Go. They are deploying their sample chain code for the start, and they are trying to download the Docker images where we require. And they are generating the certificates now, certificate authority based certificates for each and every components that we defined. So it's up and running now, and show you. And it's still generating certificates. It will take some time. And also it's possible to define whether we require the initialization or not, but yeah, we are doing the initialization and starting the creating the ledger for the first time when we initialize the ledger as well. So for the moment, for this sample simple chain code that they have defined, they're trying to call in function with these parameters. So I'll show you when we try to deploy our service, our contract, what will happen in the next phases. So it has generated all the certificates, and it's try to start the network now. So when the network start, I'll show you how much configuration files that we have to write if we are writing it from the scratch, but what sort of service that Minifabric is doing for us by setting up all the things that we require. So it has started the PS for us, it has started the orders for us, and the certificate authorities there. And if you go and see now, there are a lot of containers running, which will set up the Fabric network for you. And it's creating my channel now. I haven't defined a channel name, but so it will go with the default channel name that we didn't define the channel name here. So it will go with my channel, and it's trying to join the channel. So in this channel join part, this PS will try to join that channel, and it will create the profiles for each and every components as well. So now it's trying to install the chain code, simple chain code, which is default for that this Minifabric. So they are installing it whenever we start a network. So if you look at the files inside now, this folder was empty when we are starting the network. So all the related data for the network will be placed inside VAS folder, and it's secured as well. And all this Genesis block is the place where we say it's not possible to view. It's a block thing. So this block cannot be changed, and it contains all the policies as well as configuration that they have agreed, the organization agreed upon the start. And next, if you want to have a client application, you can place them here. And if you want to have a chain code deploy, you can place them here in the network. So currently it's deployed the simple chain code. So there's a simple chain code mentioned here, but we are not going to use that. We are using our own. But yeah, they are providing a set of chain codes for us to do the deployment and see. And there are a lot of configurations getting generated. So at the moment, the chain code installation is done, and it's approving the chain code, which will approve the chain code in all the peers, and then it commits the chain code after approval, get the approval from the peers, and then it initializes with the init functionality mentioned in here. This will create the first record in the list of this that they are maintaining inside their chain code. So the endorser related policies can be found here. So I mentioned in earlier, there are policies, and endorser policy is the one which defines who are the peers that needs to approve in order to commit a transaction to the ledger. So these things are these policies are defining this in part. So now we can, if we see here, there should be, yeah, so we can see the certificate authorities, we can see the orders that we have defined, we can see the number of peers that we requested. So these are somewhat my words. And yes, and here we can see the simple chain code that they have deployed as well. So this is the network related stuff, and this is the chain code deployment stuff. Yeah, this is how they set up the Fabric network, and there are a lot of containers when we go forward. Okay, and now I'll try to deploy our chain code into the application. So first, what we had to do is I showed you there's a folder to place the chain codes. So we had to go inside there. Okay, I'm inside the chain code now. So I'll create a folder named Logistic contract. And I'll go inside the Logistic contract. That's it. So at the moment, this folder is empty. I'm going to place all the code related to our smart contracts inside this folder. So I have placed my smart contracts in this path. So here, logistic blockchain. So I have all related data here. So I'm trying to copy that into my current folder. First, I have to create a directory in order to define the language of the smart contract. So I have to create a directory node, and Node.js is the language that we have used in order to develop logistic contract. So we have to create a folder named Node. Now I'm going inside it, and now I'm trying to copy. Okay, and now we have all the files which we have inside the smart contract that we talked about here. And now we are ready to do the deployment. So we can go back again to the page that we have the minifab file. So we are back in the root of the network file. So inside vars chain code, we have placed our chain code details, chain code related code. So now we can install our chain code. So in here, I'm saying, okay, the name of the chain code that you have to follow is logistic contract. So it will try to find logistic contract folder inside this chain code folder that you can see here. So it will try to find this one with the name, and it will try to create the tar file which requires it to do the deployment, as you can see. And this is the files that we pasted here. And I can define number of, what is the version. So you can, if you want to do a newer version of install a new version of the logistic contract, it's possible to define the version number here. It's very easy for you to define. And I'm defining what is the language, expose things, and what is the initialization method in this chain code. So as you remember, in logistic smart contract, we used init ledger, and I mentioned for one chain code we can only contact one initialization method. That's why I mentioned, because we can only talk to this initialization method. So it will now try to install it. So it's installed. Now we have to do some sort of approval. So we have to get the approval from the other peers first, because we are using the default policy for the endorsement of this, which means we require the approval from other peers as well. So for that, we can use minifab approval. And then we can do minifab commit. So as you can see, nothing failed at the moment. Okay, now we can do initialization. So this will actually create the first mock objects for us that we defined here. This will create the list that we wanted, order list and the user list, and it will first push these two objects to those lists and persist them in the blockchain. So I want to show some sort of invocation for you to get that mock object. So we can try to invoke. So for my invocation of get order function, I need two parameters: the ID of the order and the email of the user. So if I go back here, you can see to get an order what we required, we need the order ID and the user email. So from this minifabric CLI itself, you can try to do the invocation and see whether you have started the ledger and whether you have the mocked objects are there and things are working fine. So we can execute it like this and wait for a few moments, and we see, yeah, we get the chain code invocation result. So this is possible only inside like this to get these kind of data through the Minifab CLI. But if you want to expose this outside and get details, invoke these endpoints, we need, as I mentioned, the API gateway. So now let's see how to how to do the API gateway deployment. So first we have to kind of create the connection profile. So this is the connection profile. So I'll walk you through a little bit on this part. So the connection profile helps you to helps the client, the API gateway, to identify the the components of the network and actually their endpoints. So as I mentioned, the connection between these two, these just these two will be established with the gRPC protocol. So you can see these are gRPC endpoints that the client gateway that uses in order to connect to the smart contracts to each and every of these components that we defined here. As you saw, there are these components in my network now. I showed you the Docker containers up and running for these components on my Fabric network. So these are the endpoints and these are the actual TLS certificates in order to provide the identification inside the network for these each and every component. So if the client wants to connect to the smart contract, he has to connect to all these orderers and peers, and then only he can then only the gateway can establish connection with the smart contract. So that's about the connection profile. So we need a connection profile in order to proceed with the API gateway deployment. So I told you that when I'm doing the deployment, I'll show you what will be here in the config folder. So I show you here it's empty now, but now we got the fabric connection profile.json from our network. Actually, it will be coming from the network that we do the deployment. So what we have to do now is we have to paste that in our config file. So I use idea here. So that was the previous configuration. So this will be the latest configuration of our network now. So this is the connection profile that my network uses, my client uses in order to connect to the components of my network. So this is a must, and always if you want to build a client on top of Fabric, you should have this in order to connect to the endpoint. So we define this public IP, and you can see it will come up with all these configurations for us. Otherwise, we have to write it from scratch. But this mini Fabric tool helps us to be actually create this file without any work from our side. It's just it will create the connection profile for us without any problem. So that's it on the connection profile side. And I'll delete my previous wallets. Okay. First, I'll do npm run build. Build my current code base, local code base, and I'll then try to do debug. Okay, now it's connected to. I have locally deployed my client as well. It's been connected to my network as well. You can see creating a Fabric setup gateway, connected to gateway, getting the first first you enrolling the user admin and importing the ID and connecting to gateway with the wallet, and then creating the middlewares that we have defined, the routes that we have defined here. So it will check what are the routes that we have defined, and if it requires that authentication, it does for us. And yeah, then it will up and run the application for us. So we'll come into a place where we have the set of Swagger function, Swagger UI, and we can actually try to invoke this. As you can see, we need authentication bearer token here. So because from this token we are getting what is the actual token, actual client which gives this token to this issued this token. So I'll get a token first in order to invoke this endpoint. So this token is the same token that we use in Nimble. So it's like enabling SSO again, like in other services that we are doing. So we can use the same Nimble token here to do the authorization. I can close. Okay, I can try it now with the order ID that we invoked, but we don't have to pass the email, because when you pass the token, we are getting we are actually decrypting that token. If you go to jwt.io, decrypt this token, you got this token, and you can see the user email. You should see, okay, preferred username, the email of the user in our token. So we are getting, when you do the authentication token, we are taking the email in the token and kind of saving it in on the local object inside the gateway. So you don't have to pass that. Try to do this as soon as possible. So now we can pass this ID, mock ID that we used. I'll use that for the moment. Okay, we have debugger in debugger mode. I'm sorry. So it will give you the order related data. As you invoked in from the CLI, you can also now invoke from outside through HTTP call. So this is the usage of having this client gateway for this sort of application. So you can even try to see what is the party ID. We'll try another endpoint. So the involved parties are 41920, and okay, we can try it with this one and see, take orders by this party. Okay, so it will give you the order, because this this party ID is there in the involved list of parties of that mock order that we placed. So we have defined all most of the required functions that will be required to query the endpoint. So that's the process of deploying the client and the backside the smart contract of the blockchain. And now I will showcase something very cool, and what we will use in order, which is something recently added with mini fabric. So we integrated the Explorer with mini fabric. Then we can use it as a dashboard, and we can integrate this with our Nimble front end in order to view the all the blocks and transactions as happened. So I'll go to the endpoint that it exposes. Okay. Fine. And also you can find number of transactions which are involved, and what are the organization that we have inside this network, and what are the transaction, what are the blocks that has been happened, and you can get more information about one transaction from here, and the logistic contract transaction that we have proceeded with. So yeah, we can get a lot of information like this related to blockchain. So we are using Hyperledger Explorer for this purpose. Now as you can see what are the chain codes that we have deployed. So in the initialization, they deployed the simple one. So our one is logistic contract, and it has my channel as a channel name, and it has two transactions because we performed initialization of the ledgers, as well as we perform quick get operations as well. And you can see what are the channels and how many operations have been there, and number of blocks there in the ledger for a transaction. And with this dashboard, you can do quick operations like that and get some sort of an idea, and use this as a dashboard as well. You can get an idea of number of transactions happened within an hour, within minutes. So these sort of things you can get. Also, this can be integrated as an application. We can do SSO, and you can provide dashboard per each client, per each user, as we are doing in other third-party applications in EFPF. We can create a client in Keycloak, and based on the authentication, you can sort of redirect to this dashboard, and maybe we can integrate this with the Nimble front end and showcase what are the transactions going on as an analytical part of the use case. So so that's about the Hyperledger Explorer, and I wanted to showcase another thing. So between the partners in EFPF, its Coten is very popular because they are using it in order to manage the containers of their premises, as well as in their instances. So we thought about having that as well. You can create admin. Yeah, this is also possible to integrate with the Keycloak by creating Keycloak client and giving redirection. It has been already done in our EFPF deployments by the C2K team and Ali. So it's possible. Now I'll create as an admin user and give you kind of idea, because okay. Basically, this connects to the Docker sock, and okay, now I connected it. So you can see all the connectors running in the network, and because there are a lot of containers in this deployment, as you can see, for the network purpose, so you can easily manage these containers. I mean, you want to repair it, whether you want to see the volumes attached to it, whether we want to have an idea about the version of the Docker smart on the smart contract images that they are using. So if you want to have a look at on this stuff, you can easily use this container. So this is somewhat very popular with effective people now, and I I thought maybe this will be a good addition too. So that is on that side. And overall, I just wanted to point out few of the solution benefits that we are providing. We are providing abstract layer of ledger API built on top of Hyperledger Fabric Contract API 2.0.0 to extend for other business use cases. I showed you that how to extend it, and we introduced two-layer security, client security for Fabric client to perform introspection and role-based authentication for based on the token provided by third-party clients, and maintaining platform users in Ledger to provide external layer of security, verify the invoking users, and based on the roles to limit the operation of user can perform. And also we are providing a solution to easily spin up and maintain the network, easy to extend and Fabric client and provide more layer of operation based on smart contracts. You have easy access for developers with the provided OpenAPI spec and Swagger UI based on it. Easy to try out operation, no need to use Fabric test network, easier version management of smart contracts, and long-term support Fabric libraries are used. So these are sort of solutions that we are providing for you from our solution. And that's it about the presentation from my side. And thank you. If you have any questions, please raise your hand.
Hi, Ayush. Thanks very much. I guess all the slides are on in this Google Doc that you.
Yeah, I'll be uploading it to yeah. It's anyways shared with Violeta, but I'll upload it to on cloud as well. So yesterday's slide and today's slide will upload to yeah.
Okay, that's super. Thanks very much. Don't know if Dietmar, Violeta, anybody for comment?
To me, it was more or less information overload. I have to say.
Is it slower than yesterday?
Well, it's not easier than yesterday. Yes. One question would be to Ayush, because he showed in the last minutes some services where with IP addresses and local host, is there some documentation where to either start those services locally and where to access the server?
Yeah, we have defined how to start the network here, step by step.
Okay.
Yeah, step by step is defined here. The things that I did, even from downloading the Minifab, the tool that we're using, and defining the spec file, and setting up the network, and what are these options. Everything is defined, and then installing the chain code, what are the folders to create, and how what is the language, and how to go inside it, and how to copy the contract files, and initialize it, approve, commit, initialize. Everything that I did here was included in the documentation.
Thanks.
Okay.
Yeah, thank you very much. It was very thorough description of the solution. I have just a couple of practical questions about as manager of task 5.4, whom should I contact from now on regarding the blockchain task? Who will continue working with this, and what are the plans for further development?
Werner? think Werner will answer this question.
Well, this is as far as we got with it, and part of the knowledge transfer was to, I mean, we can maintain the thing at the level at which it is now. But if you want to develop it further, then people will have to see where you know, bring in their own staff and competences as well.
Yes, I see that the last part of the presentation showed some possibilities for building other applications on top of this.
Yeah. This is the point. The infrastructure. The point is the infrastructure is there. Dietmar will probably get up to enough speed to maintain the infrastructure, but we're not. It's not planned to do anything far beyond that. So yeah, I think that's the positions of that we have.
Yes.
All right then.
It will be interesting to see if anyone plans to work with this in the open calls.
Yeah, that's another question, but we'll see that in the discussion then with or in the when we know about the evaluation of the open calls, then we will see whether there is a specific need on that.
But thanks again, very good documentation.
Yeah. Yes, I would also like to thank Ayush for thorough work for all this time that he has been with us, and also for preparing this very thorough presentation here. It is information overload for anybody who doesn't work with that on a, I don't know, 3-4 hour daily basis. But it's really appreciated, Ayush, what you have done, and all the best for whatever you do next. Okay.
Thanks a lot. Thanks a lot.
Thanks a lot.
Yeah, and
yeah.
My 50 cents will be. I think it will be a huge effort to catch up all the things which are present right now, to grasp all what presented and done so far, and to add, for example, more functionality if the request comes up. That must be a joint effort of the consortium, I think.
Yeah, sure.
So I'll be at the office till 14th. If any question related to that, I can have a session with Dietmar or on that. Yes, if you have any questions, I'll be here anyways.
Okay. How long are you going to be here, Ayush? I didn't hear that.
I asked from Dagmar to give me the key till 14th. Anyways, today is my last working day, but I'll be at the office till 14th.
Okay. Well, that's basically now 1400.
14th of April. I'll be there. I will be giving the keys on 14th. Yes.
Okay.
Wednesday next week.
Yeah. All right. So shall we close for today?
Well, at least I stop recording now.
Okay.